All right. So we're just one tiny little minute late. Everyone was enjoying themselves with the drinks. And so apologies to the people online. As we mentioned a little bit earlier before, we're going to be continuing the session with Frank. We'll be addressing cloud automation. So I'm going to hand out the floor over to Frank.
Okay, thank you very much again, Clara. Okay, we're going to switch over to these slides here. Okay, thank you very much. As Clara mentioned, we're going to be talking about cloud security automation, talking a little bit more about DevOps and how we can automate some of our various activities. As people are trickling back in here, I'll skip over the introduction slide because we've all met here approximately an hour ago. And just a heads up, you will see maybe a few duplicate slides from the last one, just from a mental level setting perspective, but I won't spend too long on those slides that you've seen before. But in this particular session, what are we gonna cover? Number one, well, we're gonna cover 4 things. Number one, we wanna make sure we're all on the same page. So we're gonna cover some DevSecOps foundations here. Then we're gonna move in and talk about automating specifically code analysis. But then we'll also talk about some infrastructure as code hardening, how we can automate some of those checks. And then we will see at the very end a cool automated remediation example. So 4 different topics that we're going to be covering here over the next roughly hour or so. But before we get into the details here, I want to first talk about, well, why? Why DevOps and why specifically DevSecOps? Now, everybody online, I believe you can see this no problem, but sorry for everybody in the back of the room here, so I'll explain this a little bit. Every single year, IBM and Ponemon Institute, they come together and they publish their annual data breach report, right? The cost of data breach report. And this cost of data breach report in the latest edition highlighted a very interesting finding. And they said that, hey, based upon right, the key factors, the key protections, capabilities that different organizations had in their environments, well, there was one thing in particular that IBM and Ponemon saw that was the most effective at lowering the cost of a data breach. And as you can see here on the far right-hand side, for everybody in the back, it says, if you have a DevSecOps approach at work, that had the biggest impact in lowering the total cost of the data breach, approximately $250K, according to their research, right? So this is very interesting, right? Because one of the biggest challenges that we have in security is making sure that, hey, the organization is doing the right thing. Now, why? Why do we think that this has such a big impact? Well, the question then becomes, what is DevOps, right? And a lot of times we might think that DevOps is a tool, DevOps is a technology. We talked about DevOps, CI/CD, the common tools like Jenkins, GitHub, GitLab, and so on, but it's not really that. In the early days of DevOps, well, let me tell you an example. I'm gonna ask you to guess something. When I first started my career, I was working at a company, and I'm gonna ask you to guess, how many times per year did we deploy a new version of the application to production? Simona says 1 time, 3 times, once a quarter, 4 times, less than 1. Now, not me. I have some friends that say, well, hey, that's a funny question because I deployed to production 0 times in my whole life at their prior companies. But we deployed to production, yes, exactly right, 0.7 times a year. That was once every 18 months. And at the 18-month mark, everybody on the team, the engineers, the developers, the managers, the administrators, the testers, the business, would all get together in a big conference room like this and stay all weekend to try to deploy that version of the application to production. We all hated it, right? Because invariably, many things went wrong over the course of that weekend, and we could not move fast enough. So certainly, there was a technology issue there, but there were other issues. And that's why when we say, what is DevOps? DevOps, the term, the concept originally came up when John Willis, right, gave a talk at the annual O'Reilly Velocity Conference many years ago. And he said 10 plus deploys. His talk was entitled 10 plus deploys per day, Dev plus Ops cooperation at Flickr, the photo sharing service that was bought by Yahoo back in the day. And when they gave this presentation, everybody's jaws dropped. I couldn't believe it. I was deploying to production 0.7 times a year, right? But they were deploying to production 10 plus times a day, right? And they said, how can this potentially be done? Right? Then shortly thereafter, right, within the next 6 months or so, the term, even though they had dev plus ops cooperation, the term DevOps actually was first coined by a guy here in Belgium. He was the first one to actually combine the two words, right, DevOps, into one word. And he started the DevOps Days, various events, a long time ago. Around that time, right, John Willis posted a blog post. What does DevOps mean to me? And he said, DevOps means to me at the time 4 things, turned into 5 later, CALMs or CAMs. It means culture, right? Automation, lean, measurement, and sharing. Now, where's technology here? Right? There's no T, right? It's because DevOps is about working with others. When I was deploying 0.7 times a year, who was unhappy? Everybody was unhappy, right? And we were all mad, the engineers, the business, everybody. And so what did we do? We said, we got to get a little bit better. We need to adopt some agile development approaches. And so what did? We had daily meetings, weekly meetings, daily stand-up meetings, weekly sprints with the business. So the engineering teams, the testers, and the business work together more closely every single day. And who was happier? We in engineering, and the business was happier because then they could define what's going into the next update, and every week or two, they would see some progress. But there was still a problem. Once that 2-week sprint was done, we had the functionality ready, but we had to give it over the wall to the ops team to eventually push it into production. And this is how DevOps evolved to say, hey, it's about a culture of everybody working together based upon the backbone of automation. Deploying to production is not a technology limitation. It's a, as we said, business decision. And you got to apply some lean engineering. Don't wait for the big bang approach. Now, some organizations, right, you might still use a big bang approach, like if you're launching a space shuttle, right? But a lot of cases, most business cases, you can use more leaner approaches, defining a MVP, minimal viable product, as is written about in the lean engineering book. And you can have various measurements to measure how well you're doing, and share your ideas along the way. We talk about sharing here because some organizations go even so far as to publish online recordings on YouTube of their after action reviews. Now that's probably a little too far for most of us, right? But that's an example of the types of DevOps thinking and DevOps culture. There is a concept of a DevOps unicorn. Heard about this before, right? Unicorn is an overloaded term, right? It's the mythical animal. In the startup world, it's a company that's received $1 billion valuation. But in the DevOps world, a unicorn refers to a company, usually an internet company, that has contributed a lot to the industry success of DevOps. We've highlighted 3 of them here. Netflix was the first big customer of AWS. They moved all of their traditional on-premise infrastructure to AWS and said, we're not experts in managing IT infrastructure. So we're going to outsource our data centers to the AWS API. And in the early days, they had a big hand in helping inform a lot of the AWS services as we know them today. Amazon itself, right, related to this culture, they still today have this concept of a 2-pizza team. If you have a team that is so big that it can't be fed by 2 pizzas, then you got to make the team smaller, right, to try to keep things lean here, right? Etsy. Now, the folks, right, at Flickr that I mentioned, they eventually moved to Etsy, right? And then they built their overall DevOps program at Etsy and contributed many different open source tools. Etsy also published different metrics related tools, and they've had such a focus on metrics that they said internally, hey, we follow only one thing. We only follow one religion, and that is the Church of Graphs. Right? Etsy also famously, back in the early days, they would have non-technical people. Remember we talked about the CI/CD pipeline, pushing stuff to production, right? Etsy would have product managers, non-technical people on their first day of work, push, enter, right, to automatically deploy a change to production, and even had pictures of cats, the cats pushing the paw on the enter button to deploy a change to production, right? This is how seriously they took this from a cultural perspective. Now, the problem though is, I've spent most of my career at various large enterprises, probably 80%. And so maybe this resonates with you here in the room too, is that, hey, well, sure, Frank, of course, any one of these internet companies can do DevOps, right? Because, hey, they are a more nimble, technology-based organization. But, well, working at traditional enterprises, there have been many that have successfully adopted and pushed forward the state of DevOps. And those organizations are referred to as DevOps horses, right? So I've seen many DevOps horses over the years. And so it is definitely, yes, possible for us to do all of this. But one big barrier is the security culture, right? Remember my friend who I was drinking beer with and he said, I hate DevOps, right? Because he had a security only mindset. So what we just talked about with small teams, 2 pizza teams, pushing changes to production, having the cat push a change to production, do you see how that would conflict with traditional security culture? Because we in security, we're typically the ones that are seen to say, I heard somebody, I see Chris mouth it, say no, right? Traditionally, security is seen as the team that says no. So as a result, right, top-down, access information on a need-to-know basis versus broad information sharing, zero failure versus failing fast, right? So as a result, there's a traditional conflict between us in security and DevOps that we have to eventually figure out how to resolve. Example, not DevOps specific, but I was once at an organization reporting to the CISO. The CISO was my boss. And he came in, he was a new person in the org, and he came in and looked around and said, I don't like it here. We need to change the culture of our organization to be more like a financial institution. Do you think he was successful or not successful? Yeah, it didn't work out very well. Now, this is a large multi-billion-dollar organization, so he still made it for 2 years. But immediately, right, he even went so far very quickly to hire a director, literally with the title of cultural change. So immediately, the organizational antibodies started attacking him, right, rigorously. And so, yes, he had a very hard time the entire time he was there. So we always have to factor in, right, the culture and how security fits into that. But this is not all to say that security is all rainbows and sunshine in DevOps, or DevOps is all rainbows and sunshine. There are some challenges that we need to consider. There are various risks, issues related to DevOps, right? When we are centralizing all of our processes in CI/CD, in our DevOps tool chain, in our CI/CD solution, in our tool, now what? That is a pretty juicy target for attackers. Because what can happen if the attacker compromises our build process? Right? They could potentially, as we saw in the SolarWinds attack, they can inject some malicious code that gets distributed out to production or various customers and so on. So our DevOps server, our CI/CD server, is an example, big example of one of the pets, right? That we need to pay very close attention to and give it its love and care and feeding. There's also various other related technologies, containers, that cloud native infrastructure that we talked about before, that we've got to pay even more attention to secure. Now, whose security team here, before a new version of the application goes to production, right? It might be required that your team needs to do an assessment of that application before it goes to production. Does this sound familiar? All right. So how long do you allocate your security team to do that assessment? What's the range of time that you would allocate your team to do that assessment? 1 day? That's very fast. You have a very efficient team. No? It used to be, right, in some prior lives, well, we would allocate, depending, of course, on the size of the application, the nature of it, what type of application, what type of data it was, we would allocate upwards of 2 weeks. 2 weeks to do that assessment. But whether it be 1 to 14 days, can you tell the development team, you know what, just wait 24 hours, stop everything, because we need a stable version of the application to test. Wait 1 day, even if it's 1 day only. Are they going to wait? Well, it depends on your environment. Depends on your environment. In my environments, they don't want to wait, right? So because we need to do it at the speed of business. But in terms of the risks, to summarize, OWASP, the Open Web Application Security Project, has a number of useful resources, the traditional OWASP Top 10, the OWASP Top 10 for LLMs, but also the OWASP Top 10 for CI, CD, continuous integration, continuous delivery risks. Now, I won't read through all of these right now, but this is a good resource to go ahead to see what do we need to do to harden your CI/CD system, your CI/CD server, and your overall process. Now, in terms of these, what are some things that you would want to do if we distill down some of those best practices? Well, of course, you've got to restrict what actually gets put into production. This is why it's not just about the technology, it's about the process. Remember the difference between continuous delivery and continuous deployment, automatically pushing something to production, eliminating those long-lived credentials, protecting the supply chain, right? We'll mention some examples of this related to the software bill of materials a little bit later. But it takes a lot of work to patch your CI/CD system, right? To constantly keep it updated. That is one of the reasons, right? Cloud-hosted CI/CD systems are becoming a little bit more widespread. Somebody was telling me at the break, a little bit more widespread, maybe not so much yet in Europe, but definitely in the US, right? We see them very much more widespread. Now, why are we talking about all of this? What is the big benefit for us in security? The main benefit of DevOps is closing the window of exposure. Closing the window of exposure, right? To eliminate, right, the opportunity that an attacker has to potentially do something bad. That SSRF vulnerability that we talked about earlier today, how long do you think it will take a developer to fix that SSRF vulnerability? What is your guess? It's not a trick question. A day or three, 1 to 3 days? Any other guesses? 5 minutes. Yes, it depends. It depends. Is that developer on the team? How knowledgeable are they about the code base? 5 minutes might be a little bit fast, but a knowledgeable developer that knows what it is and knows the code base, they could probably fix it in 15 to 30 minutes. Now, why do we say 1 to 3 days? Well, there needs to be testing. There's other factors that are involved. They need to send it to all of the different environments and all of that stuff. I've seen a vulnerability that can be fixed by the developer in 30 minutes take 3 weeks to go into production, right? Because of the overall checks, the process, and so on. But that vulnerability still exists for 3 weeks then on your website, on your application. So the window of exposure is potentially long. But by being able to automate, right, a good portion of this, you are closing the window of exposure here, right, to make it easier to roll out issues. One thing that people say is that, well, you know what? If we are deploying so many changes per day, isn't it more risky? Isn't it more risky to do 1 million changes a day? Yes or no? Well, when we had the big bang approach, when I was deploying to production 0.7 times per year, it was actually riskier because it was pretty much guaranteed that numerous things were going to go wrong over that weekend because we had not practiced it for 18 months, right? So the DevOps approach actually leads you to practice and deploy more frequently. And because the blast radius is smaller, it's easier to roll back any changes that you might need to roll back or take back. Now, we already saw this version and the next one of this slide in the prior session, so I'm not going to talk about this one here too much, but this process, right, the DevOps workflow, the DevOps process is the backbone of what we're talking about from a CI/CD perspective, and the corresponding various security activities that you can automate include as part of your overall process. But you know what? We've been talking together for over 1.5 hours, almost 2 hours, and I think I have yet to use the most common buzzword. Maybe did I use it on accident in passing? Right? Is AI, is Gen AI, right? That is on top of everybody's mind. Now, it turns out that Gen AI has the promise, right? It's still early days to help many different activities from a security perspective. If you've got this continuous process, this infinite process, if you will, of DevOps, well, there's many portions of this process that Gen AI can potentially help us to do better at, right? Do more effectively with less labor. Whether that be on the far left-hand side from a coding perspective, we'll see an example here on the next slide, right, in terms of code reviews. Whether that be from a planning perspective. Now, one of the areas that has been hardest historically for us in security to automate in some fashion is threat modeling. Threat modeling is understanding the attack vectors, understanding the architecture, understanding, right, what attackers might actually do. And I've been in some situations where, is there any documentation, an architecture diagram, anything, something to tell us, give more information about how the system works? And on the extreme end, the teams have responded and said, well, here's the link to the Git code repository. The code is self-documenting, just read the code, right? Not that helpful. Now it can be done, but it makes it a lot more labor intensive. Now you could potentially use Gen AI to speed up parts of that process overall, right? And then whether it be from a testing perspective, whether it be from a moving to production and deployment perspective as well. Here on the next slide is an example of Microsoft's Copilot. Who here has used Copilot? Anybody? A handful of folks? All right. Now, you can't read this from the very back, so I'll just mention a couple things. Now, we passed in some infrastructure as code, some Terraform code, and we asked Copilot, hey, are there any security-related concerns related to this code? And Copilot kindly comes up with a long list of potential things to look at. Now, there's a catch, though. Does this tell us exactly what to do? Right? If you look at this, it says, well, think about how your keys are managed, think about your user data, think about your IP address, and so on. But it doesn't tell us the specific things that we need to do. A smart security person still needs to read this and say, okay, well, is this accurate? Is this not? And I need to go investigate. But there are some hints. There are some breadcrumbs that we could potentially follow. You can't see this again, but number 3 says security groups. And as we mentioned in the morning session, prior session, security group is your AWS stateful firewall. And it specifically says, hey, there's something you might want to pay attention to in your management bastion security group configuration. I highlight this one here because we're going to see this come up later on in this session with a couple demos. Right? We're going to have a few basic demos here in a little bit, or as we go through the session. And so, yeah, Copilot can definitely help. When I was an engineer and developer, one of the things I hated doing the most was writing reports, recommendations. Well, this is when I was very technical. So I wasn't even at the report stage of my career, actually, right? So one of the things that I hated doing most at that early technical stage of my career was writing explanations. Well, and those explanations have to come in the form of code, was writing unit tests. Right? I always hated writing unit tests because I just wanted to write the code itself. I didn't want to write the unit tests. But now you can write security unit tests, a starting point based on Gen AI. Right? So it makes some of these mundane activities like reports, like analysis, like explanations, a little bit easier to do. Now you can't just copy and paste those, right? But it's much easier to start with something on the paper versus nothing on the paper. We already saw this slide before, so I'll just highlight, yes, again, the difference between continuous delivery at the top versus continuous deployment at the bottom. It's up to you, right, on when to do it. The way I keep track of it in my mind is that they're in alphabetical order, right? First one alphabetically, right, that's the one where you stop. The second one is where you go all the way. We mentioned some tools, but the key tools here, it turns out there's a confluence of tools in the sense that all of the original Git version control systems, GitHub, GitLab, and so on, Bitbucket, right? Those have all since expanded to have CI/CD functionality as well. Quick trivia, does anybody know who created the free open source Git code base project that now the commercial versions are based upon? Say that again? Yes, Linus Torvalds, the creator of Linux, created Git. Because all Linux, right, is a global community of contributors, and Linus was frustrated by the fact that it was hard to have all of these global contributors contribute to codebase using traditional source code management tools, so he created Git from scratch to help solve those various problems. All right, again, this is hard to see from the very back, but this is an example of your Jenkins pipeline. And the way that we've defined this here on the far left is your commit phase. The code has been checked in, the commit phase automatically kicks off, CI, the acceptance phase kicks off, continuous delivery based upon the packaged application, the container, then gets deployed to other environments. But the main thing here on the far right-hand side is that, you can choose. Normally, there would be literally a play button here. You could define a play button that somebody has to come and push this if they want to go either deploy to the traditional on-premise environment at the top or your cloud environment down here in the lower left-hand corner. In this example, it's AWS. Right, so an example pipeline here. All right, So those were various DevOps, DevSecOps foundations. So let's talk a little bit about automating code analysis. How many security scanning tools are you going to have in your environment? Now that's a little bit of a trick question because you're going to have a ton of them, right? You're going to have a lot. You're going to have a lot of different security scanning tools. And usually what happens is your security team is going to have some sort of scanning factory, some sort of scanning pipeline that contains a number of different tools, some examples that you see here in the middle of the slide. Now, we've specifically used various free open source tools just for reference so that we're not necessarily talking about a specific vendor, but all of the code comes in from the various repositories, goes through the scanning pipeline, and as we're going to see at the very end, the very last demo, what we talked about in the prior session is that depending on what happens, you might have some automation kick off via Lambda that could take some sort of action, activity, whether that be from a metrics perspective, a Slack notification, opening a Jira ticket, whatever it might be, right? So this is the common modern workflow that hopefully many of you are experiencing firsthand. Now, from a technical perspective, if you've got this plethora of tools, you've got dozens and dozens of different tools, well, how do you go about automating it? Automating the results, the findings, depends upon using a common reporting format. As you can see here, there's a number of common reporting formats that your tools, you can configure them to output in a certain format. JUnit, XUnit format is a common one. Check style, serif, is becoming even more and more popular based on a JSON syntax, right? And there are others from a supply chain software bill of materials perspective like Cyclone DX and so on. The main thing is to make sure that your tools use one or more of these common reporting formats so that then your engineers can automate, right, the processing of those various results. Here is just an example of what this looks like in JSON, right? We've got a formatted SQL string here. There's some sort of SQL, SQL injection that's going on, right? And what that would look like in your pipeline, specifically using the open source, but also now commercial version of the SEMgrep tool. Here's what it would look like from a serif perspective, right? Again, this is a format that's gaining more and more popularity as well, and how that appears to be displayed in VS Code, Visual Studio Code, the leading, right, code editor now that most people are actually using. So from a DevOps perspective, of course, the application code, right? When the teams would tell me in the past, hey, there's no documentation, just go read the code. Everything's in the code. Well, the catch is we want ideally everything to be code, whether that be documentation. So now I don't write my documents in Microsoft Word, or technical documents, I should say, anymore, right? I write my technical documents in, oh, what did you guys say? Oh, I couldn't hear you. Oh, yes, thank you very much. In Markdown, yes, in Markdown. So it's not just your application source code, but it's other documentation, your configuration management code, your infrastructure code. We saw an example of that, right, in the last presentation, right? Because all of that code can then be analyzed, by a static analysis tool like SEMgrep, right? The static analysis tool landscape, right, it's been around forever, right? SEMgrep is one of the newer leading tools that gives you a lot of flexibility to, right, use their out-of-the-box rules, but create your own rules as well for the most common programming languages, but for other, right, configuration files, other infrastructure as code files, and so on as well. Here is an example, right, of SEMgrep scan results in terms of what this looks like. You'll see an example of running another scanning tool here in a little bit. Now, when you use one of these tools, right, the tool, off-the-shelf tool, does it know everything about your application code? No, of course not, right? So there are times when your code base, your engineering teams have built up some libraries, and maybe it does some security checks, some sanitization, some output encoding, some input validation, and so on. But the tool out of the box isn't going to know it. So as a result, you might need to modify the rules, write some custom rules to know about, hey, the sanitization that occurs, or write some custom rules that are related to certain checks that you actually want to have happen. Right? So this is why you'd want to have a flexible tool like this that allows you to create, right, those various custom rules. And in terms of integrating it into your CI/CD pipeline, we've mentioned Jenkins a number of times. but we're going to show some examples of using a cloud native solution, specifically GitLab here, where you can say, hey, I want the results to go to this particular directory, right? And the particular artifacts, the corresponding result in JUnit format down at the bottom will be put into these particular locations that can then be used for downstream processing. All right, I'm going to pause for a moment here. Any questions? Complaints can be directed to Freddie when he comes up in his next session. All right, so I'm going to switch over to a very basic demo. This first demo is really just to get you oriented to the corresponding environments, right, where is related to the upcoming demos that you're going to see. So switching over to my demo screen here. Now you can see that I've got a number of tabs that are open, right? But we got this first tab and it's on I'm logged into my GitLab environment here. And in GitLab, one of the more popular CI/CD solutions, from a GitLab perspective, right, we want to look at a number of different things. Like you can see in my test environment, I've got a lot of projects here already that are used for different purposes. So we are deploying our infrastructure here, right, our infrastructure to AWS. How's that in the back? I'm going to make this a little bit bigger. Is that okay for everybody in the back? All right, thank you very much. We also have the ability to deploy our infrastructure to Azure if we want, but we've got other applications. We've got our DM web code for the web portion of our application. And where did it go? It's DM API, right? Because our Dunder Mifflin application, that I'm going to switch tabs here, right? Switching to this tab, this is the application, right? You guys are probably familiar with the TV show The Office, right? This is based on the US version of the Office. And here you can sign into the application, and Michael Scott, the manager, he can do various things and administer people's HR records and so on. Well, this web app is hosted via the web application code, but when you click sign on, under the hood, it utilizes various API code to call the authentication functionality, right? And so those were the projects that you saw on the other tab. So going back to the GitLab project, I'm just going to go ahead and go into the DM API, Dunder Mifflin API project, and clicking on that here, right, you can see, I'm going to make it a little bit smaller so that I could see the side view here, right, so I can get the navigation. And then in the build, you can see under the build tab, we got a pipeline defined for this project. And this pipeline has been run a few times in my testing here. And in the most recent one, right, you can see that I ran specifically another static analysis tool called Trivi, right, that did some basic checks. So when we take a look at this overall, right, we click on this and it says pass. We can see the details of the pipeline here in terms of the various tools that it runs in terms of automating these different checks to ultimately then deploy on the far right-hand side to, in our case, in our testing classroom environments, we allow people to deploy to either AWS, Azure, or both, right? Because there are subtle differences between the two environments. And all of this configuration happens, right? So all of this, if I go over now to a different tab, I'm going to go over to Visual Studio Code. And in VS Code, this is a little small. Try to make this a little bit bigger. I'm going to open up the API project. Now you can see it's cycling here, so maybe there's something wrong with the connection. I'm going to go ahead and try to refresh the overall page. All right, that seems to have done it. So that API project is exactly what we were just looking at in GitLab, but this is where all of the code is in the SRC directory. But the GitLab configuration is specifically in this gitlab.ci.yaml file. I'm going to expand this over. And if we scroll a little bit, hopefully you remember that, hey, what we saw on the screen, we define it in code, right? So there's check tools AWS, check tools AZ, all the way down to, down here, what we just saw was deploy to AWS and deploy to Azure. So notice that the main thing to keep in mind here is that, hey, all of the configuration even happens in code itself. All right, so this is just an introduction to the environment that is similar, hopefully, to all of the environments that your engineering teams are using as well. All right, if we could switch back to the slides now. Thank you very much. All right, so we're going to go ahead and move on to the next topic here, which is infrastructure as code hardening. And when we talk about infrastructure as code, there's at a high level, there's two different things to consider. Is number one, you've got to have some way to configure and deploy your servers, your Windows servers, your Linux servers, and so on. The tools on the left-hand side of this slide are your various configuration management tools that have been around for a long time in the industry. Chef, Puppet, Salt, and so on, that allow you to configure your servers, your Windows machine, your Linux machine. But once you do that, the catch is you've then got to what? Deploy those servers to where? You've got to deploy them to your environment. In our case, what we're talking about is your cloud environment. So on the right-hand side, you've got various other cloud-based infrastructure as code tools, and the cloud providers all have their specific version. AWS has CloudFormation, Azure has Azure Resource Manager, Google has Google Deployment Manager. You saw an example of AWS CloudFormation earlier, but the catch is that most organizations that I see, large organizations, are multi-cloud. Every large organization that I see has not, for example, has Linux, both Linux and Windows, but every large organization I see has multiple cloud providers. Some maybe more than others in terms of percentages, but because of that, your engineers, they don't want to write code just in AWS CloudFormation and also duplicate it in Resource Manager. So in the lower right-hand corner, the industry standard approach has become to write your code with HashiCorp's Terraform, right? Now, there's a little bit of hesitance now, right? Because who acquired HashiCorp? Oh, not Amazon. IBM. IBM acquired HashiCorp. That's the owner of the Terraform project. So people are a little bit nervous, worried. What is the future of HashiCorp? What's the future of Terraform going to be? I don't think it's going anywhere, but people are a little bit concerned. So just FYI. So the main point here is that with Terraform, you can write code mostly in the HashiCorp configuration language HCL. Then certain other parts, you might need to use some cloud-specific language or commands. But for the most part, right, people are using Terraform. We saw an example of this AWS CloudFormation code before, right? So I won't go into all of the details, but this is just to highlight that, hey, you got some infrastructure code here, right? And then because of your infrastructure code, you want to go ahead and automate, right? Automate all of your checks around this. How do you go about scanning this code? Number of different tools that you could potentially use. Again, these are some open source versions. You've got Terrascan, SemGrep that we mentioned, and so on, that you can use to scan your various environments, your various code bases. Now, this is a new one. We haven't seen this yet because it's not just your server code, configuration management code. It's not just your cloud infrastructure as code, right? That allows you to deploy your cloud VM and your cloud network infrastructure. Because the whole point of moving to the cloud is to deploy new features and functionality more faster, more effectively, and so on, more securely. But you deploy your applications in the form of a container, cloud native, right? And so that's how they tie together. So once you've got your cloud VM, your server, you need to deploy your functionality on it. You do so in the form of a container that is created via a configuration file like this, a Docker file. All right, now check it out. Does anybody know there are a number of bugs actually with this code? Can anybody identify one bug? Yes, I see a hand. What line number? Line number 15, a big one here because this container is running as root, the most elevated privileges. And unlike traditional VMs, virtual machines, that have strict separation between the VM and the host, containers have lightweight, if you will, by comparison, separation between the container and host. So if somebody is able to compromise the container, they will have, in this particular case, root access on the container and potentially root access on the underlying host as well. That's bad. All right, anybody else? Line 7, all right. So in this particular case, you're installing a particular library, but one of the issues is on the far right-hand side of line number 7, there's a star, but specifically it's pinned to version 1.1 star. So now maybe if this is a testing environment, you want to keep that testing environment that's isolated separate, maybe that's okay. But this means that you're always pinning to an older version, which is potentially vulnerable, right? So that's a potential problem. Anybody identify anything else? Line number 10, right? Say that again. The number of days, so you're generating a certificate and it's valid for 10 years. That's probably not too good. It's an indication of poor uh, certificate management processes here. Yeah, that is a good one. There's another very subtle one and a blatant one. I see a hand back there. Excellent catch. That's very hard to see, right? It's like a little phishing attack type of thing. Line number 1, it's not Microsoft.com, it's ourmicrosoft.com. So you're potentially downloading the base image, right? From a vulnerable vulnerable base image potentially here. Very good. Did I see another hand? Yes, go ahead. Line 5, yes, you've got the hard-coded passphrase here. That's very bad. We talked about this before. Okay, same one. I think you guys got everything, if not even more so, because as we see here, oh, okay, yeah. One thing we didn't mention is at the top 2.2, the unsupported SDK version, an old version of Microsoft's .NET. We got the hard-coded password. We got the pinning of the package version running as root. And I didn't highlight here the long certificate expiration. So that was a very good one. Very nicely done. Who needs Gen AI and who needs this automated pipeline when we've got all of you? You just did it right away. Nice work, everybody. All right, now this gets us to various container image vulnerabilities here. And we've mentioned in conversation, the software supply chain, right? And if you're downloading a base image or a dependent image that has some vulnerabilities itself in it, you are inheriting those various vulnerabilities. MITRE ATT&CK specifically calls this out in terms of implanting an internal image, and this is related to potentially a compromise of your CI/CD process, potentially your build server. And so if you compromise something, you could download that base image from an untrusted source, right? But here, how do you go ahead and mitigate these things? Well, you want to go ahead and scan your various images for, well, their provenance, but also scan them for various vulnerabilities. Maybe you want to download the images only from trusted providers. Here are some examples of some trusted container base image repositories that you could use. But that's just one element. One element of the part of the overall container process is downloading it from a potential trusted source here. And really what we're talking about is, yeah, everybody's favorite topic, supply chain security. Now, supply chain security, right? I was doing a board presentation once. And in the board presentation, this concept of software supply chain security came up. But I knew that people were not familiar at the board level with all of the technical details. So out of the blue, I said, because I had just eaten a burrito, right, from Chipotle back home. And I said, hey, it's kind of like a burrito. Every single day, Chipotle has to sell hundreds, if not perhaps thousands of burritos. And what are they worried about every single day? Their supply chain. Do they have enough chicken? Do they have enough guacamole? Do they have enough tomatoes? And so on. And where is it coming from? Are they coming from trusted sources? Is it potentially spoiled? Is it potentially, right, something potentially wrong with that? Similarly, as a result, right, we've got to figure out what is the source of our corresponding software. We've got to then go ahead and, in our particular case, build the software based on other dependencies, right? So if you're using a dependency from ourmicrosoft.com, that's not very good. And then you've got to go ahead and package it up. And as a result, there's a number of steps down here at the bottom, number of things that we want to consider, that we want to mitigate against in our overall software supply chain. Do you guys know about salsa? Talking about burritos, right? Salsa, right, is your supply chain levels for software artifacts, right? Now, this was defined not too long ago, right? But hey, there's, for example, level 1, provenance. Do you know, right, where that artifact, that software actually came from? Level 2, signed governance generated by a hosted build platform. So you have a little bit more assurance. And then level 3, is there some assurance of a hardened build platform? Now that one is a little bit harder to measure, right? So really we're more at level 1 and level 2 right now as an industry, but level 3 would have been very important in the SolarWinds attack, right? Because their build server, their build process actually got compromised. This is all related to the software bill of materials. Just like all the foods that we eat have a listing of all of the ingredients, what's actually in them, and so on, right? We want to basically know, hey, using a standard format, Cyclone DX and SPDX are the ones that are becoming the two most popular ones. We're going to have a software bill of materials, because it's been said, when I first started my first engineering job many years ago, we wrote pretty much all of the code in the application ourselves. Maybe 80% of the code that was in the application we wrote. But now, fast forward to today, it's been said it's the opposite. 80% of the code in your applications is not written by your team. It is based upon other open source frameworks, libraries, and other dependencies. That means only 20% of the code is written by you. So the traditional scanning tools are really looking at 20% versus 80%, right? That's why we need some visibility into that related to the software bill of materials, the corresponding list of ingredients. All right, we're going to go ahead and switch over to the demo screen here again. And we've got another basic demo here. Now, in this particular demo, there's a little bit more that we're going to look at. So I'm going to go ahead and go over to my terminal here, make this a little bit bigger. I'm going to log in, and while I'm logging in, some of you might have, hopefully I entered that password correctly, we will see. So I've gone ahead and logged in, and you might have noticed that, hey, for each of these tabs in the browser, there's different sans.labs URLs. So these are not accessible via the internet, right? These are all via hosted in a special cloud, what we call our flight simulator environment that we have set up. It can only be accessed. There's multiple protections. There's a network protection, credential protection, password protection, and so on. So if you type in these URLs right now from your browser, you won't be able to get to it, right? Because it's our secured flight simulator environment that we use in our various classes. So for the purposes of this illustration, right, the first thing that I'll do is here, where I'm in the home directory. And so I'm going to go ahead and go to my code directory. And it's always a risk to do some live demos here. All right. And let's just make sure I've got the latest. Check out from Git pull. All right. Okay, so I have the latest. Now, I typed some commands, but I don't want to type all of these commands because you don't need to see all of my typos. So I'm going to go over to a file where I've got certain commands that I want to run. So the first one that I'm going to run is this one. Again, this is just a short, basic demo here. And I'm going to type that, I'm going to paste that in. But before I run it, right, sorry for, it got a little bit cut off at the bottom here, everybody. But what we're doing, right, we've got a security scanning tool, checkoff, that is installed in a Docker container. So that's why it says Docker here. You could kind of ignore that. The main part here is that we are running at the very bottom the Chekhov scanning tool, specifically in the current source directory that I'm in. You saw me earlier switch into the infrastructure AWS directory. And I'm going to go ahead and run it. And I'm piping the output to the grep command. Specifically, I'm looking for a specific finding. And it's cut off at the bottom, but it's a CK at the bottom, AWS 24. And I'm only printing certain number of lines before and after that particular finding. All right, so just a little bit of background explanation. So I've go ahead and hit enter. I'm going to run the Chekhov scan. It's going to take a little bit of time for it to run, less than a minute, probably 20 seconds here. And once it runs, you can see that it's discovered some findings, specifically the CKV AWS 24. And earlier when we looked at the Microsoft Copilot screenshot, Microsoft Copilot said, hey, you might want to check out something related to your management bastion. And it actually correctly identified what this scanning tool just found that says, hey, there's a security group, right? AWS security group, our stateful firewall that allows ingress from anywhere on the internet, 0.0.0 to port 22. That's probably not the best thing to do, right? For your bastion host in this case. It tells us where the code is, right? Why it failed. And it specifically tells us down here at the bottom, hey, this is the corresponding configuration here. All right. So now if I go back, right, to my, VS Code, and I'm going to go ahead and close this, close the other project we had opened up earlier, go to the DM infrastructure AWS project. And if I scroll down here, right, now I totally forgot which file this was actually in. Now that we're, this is always the risk with these, the live demos. But back here, it told me what file it was in. It was in securitygroups.tf, which would totally make sense. All right, and here, right, where did it go? inbound ingress right here, right? 0.0.0. So this is when in real life your engineer would come and check this out, right? And we would change this to something a little bit more appropriate. Whoops. We would change it to, if I can get the cursor to actually work, we would change it to var.admin underscore IP underscore address. All right. And then I'm going to go ahead and save that. All right. So now we've changed it to not be from anywhere, but we've changed it to our pre-configured variable that only is our trusted IP addresses for administration purposes. So now if I go back, right, I'm just going to scroll up here a little bit and I run the same command again, right? Run the same Chekhov command. Again, it takes 20 seconds to run. Hopefully, if I typed everything correctly in the right place, you will see that that same finding does not come up, right? And you can see that just by even not reading anything, the red part is gone now. So that particular finding doesn't come up. So now that we've made the change and tested it, what do? We check in that particular code so that now in real life, in the actual deployment, hey, that issue doesn't exist. You can only SSH from, right, the trusted IP address. All right, I mentioned that these are some basic demos here. Does that make sense, everybody? All right, so let's go ahead and go back to the slides. All right, thank you very much. So this brings us to our very last topic here, which is a little bit of automated remediation. Now, there's a number of different ways that you can do this, but specifically, we're going to be showing an example from the open source Cloud Custodian tool. And I mentioned this in passing. Cloud Custodian was a tool, open source, created, published by the folks at Capital One, right? Cloud Custodian is a very useful tool. It's one of the earliest versions of your open source CSPM, right? But it also goes a little bit further because it lets you do some automated remediation. And it detects things like detecting root logins from places it shouldn't be, blocking resources, right? Configuring certain configurations if they don't meet your requirements, configuring various settings, and detecting and remediating security group violations here. Anybody used Cloud Custodian before? Played with it before? All right. So Cloud Custodian has support not only for AWS, but for other cloud providers as well, specifically in Azure, right? Because all of these cloud providers at a high level, they've got the same type of services. So you can check for this periodically, basically kind of like via a cron job type of functionality. You can go ahead and pull your Cloud Custodian policy whenever you want. And then under the hood, it could use Azure Event Grid to automate the processing of any downstream activities. So, but in terms of what we're doing, what is the configuration actually look like? This is the YAML configuration file for Cloud Custodian, where we specifically say, hey, if we find some security group violation, like the one we just manually fixed, right, what we want to do is we want to go ahead and remediate it. Because even though I just changed the code that you just saw, right, do we ever run into a situation where somebody, an administrator, logs into, let's say, AWS and then manually changes the configuration without going through the code? Sometimes that can happen, right? So if something changes in production, there sometimes could be a discrepancy between what's deployed versus the code itself. When that happens, well, ideally, you'd have some functionality to automatically detect that variance and potentially remediate it based upon the ports that you want to allow or not allow. Make sense? All right, now in AWS in particular, when you deploy that Cloud Custodian configuration file, under the hood, what actually happens? What actually gets deployed? Well, based upon whenever you do anything in AWS or any cloud provider, right? If I change the configuration of a security group, it generates a log. It generates a CloudTrail log, right? So that CloudTrail log happens, but we have defined, Cloud Custodian has defined an event bridge rule that says if something happens, if ingress rule is changed, go ahead and kick off an activity. It specifically says kick off an activity with a Lambda function that then will remediate the corresponding issue. All right? Now, what does this actually look like in AWS? We call high-risk security groups remediate at the top. We're looking for the CloudTrail log in the middle. That is there an authorized security group ingress call? Was there a log that happened? Was there an activity that happened related to changing that configuration, specifically, right? Changing it for 0.0.0 any IP address in the world. And if you detect this, well, what do? Down at the bottom, you remove the corresponding permission. All right, now let's look at some details. What does this actually look like? Well, here's the CloudTrail log of if, right? When did this actually happen? You call authorize security group ingress, changing the rule itself. Which security group in the middle did that happen for? And what is the corresponding range of IP addresses at the bottom that are allowed? Right, so that's what the log looks like if somebody does that. But then you define, or Cloud Custodian defines, an Amazon Event Bridge rule. And the rule is, hey, if there's any of these things, authorizing ingress, egress changes, revoking, right, ingress or egress changes, this is when we want to pay attention. All right. Now, because of this Event Bridge rule, then there's the CloudTrail log, there's the Event Bridge rule, and now there's the Event Bridge log. Because when something gets kicked off, it says, oh, I did this, right? So it detected here towards the top, hey, there was an ingress call on a particular security group allowing access from anywhere. And then what are we going to do? Well, the Event Bridge rule, we've defined it to call remove permissions in the lower right-hand corner. All right, and then when you call remove permissions is a Lambda function. The Lambda function, right, here, security groups remediate, under the hood has some code to go ahead and here, right, remove the corresponding permissions that were just automatically added. Does that make sense? All right, so let's do the very last demo here and getting to the very end of the presentation here. All right, so I'm going to go back to my text file here, because again, this is too much for me to type. So what I'm going to do first, I'll just paste this in before running it. Now, what we have here is we're calling the, let me make this a little bit bigger. Somehow it got, no, that's too big. There, I think that's better for you guys in the back. We are calling the AWS EC2 describe, it got cut off in the visual, describe security groups. And we're specifically saying, remember this? The DM, the management bastion security group. Remember that came up in Copilot, that came up in our code review, in our automated scan. And we're specifically saying, well, what are the IP addresses associated with this security group? So once I hit enter, right, you can see that we've got the bad configuration here, 0.0.0, right? Because I didn't push the code change. I only did the code change locally earlier, right? I didn't push that out to the environment. So the running environment still has this discrepancy. All right. So you've got 0.0.0. But if I go back here, then what I want to do is I'm going to go ahead. I need to run this command just from a setup perspective. All right. So the next command that I'm going to run is just getting the ID of the security group, right? And just setting up the next command, because this is the security group that I'm going to modify right now. I'm going to modify it to violate the cloud custodian rule that we just saw on the slides. Okay? And specifically, what I'm going to do is, if we highlight this, I'm going to run 3 commands in succession here. The first command here is I'm going to open up port 80 on the Bastion host, security group rule. I'm going to open up port 443. Should those be enabled on our Bastion host? No, probably not, right? Not available to the internet. But then immediately after I make that configuration change, I'm going to run this third command that shows what all of the current configurations are to highlight that I've made that change. Make sense? So if I go back here, and I've got to do this quickly. All right, so now you can see that not only do we have port 22, right, which is what we had before, but down here, we've also got the configuration allowing 443, and I think it scrolled up a little bit, up here, port 80, from anywhere on the internet as well. That's not good, right? But notice, I didn't do anything. I just ran that configuration. We see the configuration take effect. But what happened? Under the hood, under the covers, right, Cloud Custodian has actually run. Right? And now if I go run the command again to look at, interrogate that exact same security group, what's it going to show? right? It shows that only the port 22 is here, but port 80 and 443 are gone. Isn't that awesome? What happened? Cloud Custodian just automatically ran in the background because it looked at the CloudTrail log, kicked off the Amazon Event Bridge, kicked off the Lambda, and then it said, well, I need to remediate this. So let's automatically remove the port 80 and 443 access for that security group configuration. That's an example, a basic example of how you can do some of this automated remediation, right, in the cloud. Isn't that awesome? You guys are not as happy about this as I am. So to show you an example of that, now I'm going to the, whoops, what just happened? Of course, I signed on earlier this morning and now it's asking me to sign in again. Okay, now here in the AWS console, if I go to CloudWatch, look at the CloudWatch service. And in CloudWatch, I could see on the left-hand side, I'm going to go to the various log groups. And if I go to the appropriate log group, you can see we've got a lot of stuff here. Specifically, it's this one in the middle here, the custodian security groups remediate the functionality that was just automatically called. I click on that and I go into the latest log stream here down at the bottom. And you can see there's a bunch of stuff, but I'm just going to go ahead and filter for ingress because that's what we had been looking at. And if I go ahead and expand on this, we can see, just like we saw in the slides, right? We've got the corresponding, right? This just happened. So we've got the authorized security group ingress here, right? And we've got it for a particular security group. And we detected that this configuration was changed in this particular case. And we kicked off the automated response down here at the bottom, right? So this is a log, a trail of the activity that just actually occurred. All right. With that, I'm going to go ahead and go back to the presentation slides. And that brings us to the very end, everybody. That is the very end, right? What did we cover? Some DevOps fundamentals, DevOps foundations, automating code analysis, injecting it into your CI/CD pipeline, infrastructure as code hardening, right? Doing that scan against our infrastructure code to not only, right, find the issue via something like a Copilot, but find it in our code via the static analysis scan. But if somebody, right, makes an inappropriate configuration change, we just automated the corresponding remediation as well. So giving you a taste of what this could look like from an end-to-end, beginning-to-end perspective overall. All right, any questions? Yes. That is a very good observation. Some of you might have noticed that on the cloud custodian configuration slide that we showed, there was an option to be able to email to notify a user. So you need to know the right person's email, but you could have, yes, that was a cloud custodian specific configuration that then you can notify somebody of something. You can also, right, do a Slack notification if you want and so on, depending on what's most widely used workflow, appropriate in your environment. So yes, that's kind of getting us to back to the DevOps process, right? It's about comms, it's about sharing, right? Building that culture, and you could share by communicating, over communicating. Some people will say, now we showed the remediation here, but most security teams won't start with the remediation. They will start first by saying, look, this is what we noticed. If you don't respond to us in a day, we're going to remediate this, or whatever's appropriate time frame for your org. Make sense? A hand in the back? Every security team is worried about automated remediations. And when web application firewalls first came into the market years ago, the vendors said, hey, we've got the possibility of learning the app and we'll automate any potential response. The vast majority of WAFs that I see are still deployed in monitor-only mode. Why? Because we security teams are scared of potentially breaking some functionality. But WAFs are also used for virtual patching. Because remember that window of exposure? If you've got 3-week window of exposure, if you have a WAF deployed, you can specifically configure the WAF to say, I'm going to virtually patch this one issue against this one URL, this one URI. So it's very useful. Similarly, for these automated remediations, you're not going to do it for everything. You're going to say, what are the safest, most common use cases that we can start to automate? And once it's more rigorously understood, you enable it. And then for the vast majority of other things, you continue to learn and see what else can you potentially, if you want, do automated remediation for. Good question.
Bit in line with zero-touch infrastructure as code, how do we marry this with the response part of EDR in relation to configuration drift? Because obviously we don't want these third-party tools impacting code or state of code versus what we have in the code base.
Very good question. I'll try to repeat that, I think, so everybody in the back can hear as well. Oh, I forgot about everybody online. I'm sorry, everybody online. I should have been repeating the questions, but I think my answer indicated what the question was. But for this particular question, well, what about certain things like EDR, endpoint detection tools? What about signal from lots of other places? And what about configuration drift, right? Kind of like we just showed, right? A separation between the code versus what's in production itself. So you kind of had maybe 2 or 2.5 different questions within one, but there's a couple directions that this could go. One is that all of the big vendors are now saying, hey, look, it's not just about EDR. It's not just about your CSPM. It's about what they refer to as XDR, extended detection and response, with the idea being that, hey, eventually at some point, the vendors are going to have signal from all of these other tools, whether it be application, whether it be cloud, whether it be endpoint, whether it be identity, right? And all of these are going to kind of come together so that you can identify kind of what that is. Now, so that's one part of the question. Another part is, you mentioned specifically configuration drift. We mentioned CSPMs as a category of tools. There's a number of leading vendors in the CSPM space right now. There is Palo Alto Networks, there's Microsoft, and there's Wiz, and there's Orca, right? Those are kind of the most commonly used players. Lacework used to be doing really well. They just recently got acquired by Fortinet. There's other players in the space as well. Now, I mentioned that here because Palo Alto, over the last 5 to 10 years, has grown by acquisition. That's nothing wrong with that. But how many CSPM products have they acquired in the last 5 years? They have acquired three different CSPM products, right? Because the early versions of the CSPMs that they first acquired, let's say 5 years ago, I forget the exact timing, they are not too dissimilar from what we see with the open source CSPMs, like a Prowler or a Cloud Custodian. To be honest, basic scanning functionality. So then the market changed. There's a lot of advancements relatively quickly. So then, well, they had to acquire the next generation, version, what I call version 2 of the CSPMs. Then quickly thereafter, they acquired the 3rd generation. The 3rd generation said, we're going to try to do a little bit better to tie code to cloud, code to cloud, cloud to code, tying the infrastructure code that we saw back to what's actually deployed in the real cloud environments. That's the promise of it, right? It's getting there. It's still not fully there. Is there going to be a 4th generation of CSPM tools? Probably. The fact that Palo Alto acquired 3 different solutions in roughly 5 years, that's an indication of how fast the market is moving. So that means for you as the buyer, we're getting to the point now where things are a little bit more stable. So your EDR tool, you're probably not going to change your CrowdStrike or EDR for, let's say, a decade. Your Cisco stack, you're probably not going to change that for a decade. But your cloud tools, maybe you're going to change that in 2 years, in 3 years, right? Because that's how quickly they're changing. But that's the promise. It's in terms of looking at that configuration drift. I haven't seen yet a perfect solution. Conceptually, and as you can see, you can do things with open source and other approaches, but there's still, right, startups that are kind of trying to fill these gaps. Very good questions.
I have a bunch of questions. Oh, I realized this would work. Awesome. Thanks. So everybody can hear. So we have a few questions from online, and one of them is actually about the DevSecOps that you were talking about earlier. And so Stefan was asking, as we talk about a more API first approach, we do also see that the attack surface is shifting towards the API. So he's interested to understand how this is included or taken into account in a DevSecOps perspective.
Very good question. So you might have seen when I was quickly going through the projects in our test environment, we've tried to model it after a real world application architecture. So we not only had the infrastructure code project for Azure and AWS, we had the web project for the web front end, but we also had the API project for our test API backend. Not all, I would say many, as the commentator said, many organizations are going to a microservice-based architecture, which means there's an explosion of different microservices. Now, not everybody. Etsy, who I mentioned earlier, notably still has a monolithic, right, application deployment architecture. So it's not one is inherently better or worse. The catch is that all of the same stuff that we talked about with scanning, you've got to include that scanning in the pipeline for that API project, right? So you got to find the appropriate scanning tool for that particular code base. But then the question might also be, how do you scan the running APIs? That has always been a little bit more challenging. There are ways you can do that, but because these APIs are only internally accessed typically via the application, you can test them one-off, but what? You need the appropriate credentials. You need the certificate for your manual tester or your testing tool to test those corresponding APIs. But the good thing is that if the microservice architecture is done in the typical way, right, each microservice, each API is going to have a small bit of functionality, right? You also have API gateways, whether it be from the cloud providers or from other third-party vendors that you could use, right, to add some additional security protections, authorization, access control, rate limiting, and so on.
Thank you. And then he also had another follow-up question. So you did the demo with the Dunder Mifflin, and he was wondering if we could also access that GitHub repo to test it ourselves.
Yeah, sorry, I mentioned earlier that what I was showing is from our flight simulator environment in our courses. This is specifically from the Sec 540 course, and so no, I'm sorry, it's not publicly available. Yes.
Online can't hear you.
Frank, from your experience and the explication you did, how you see the shift from the DevOps and the Zero Trust combining together in the cloud?
What is the difference between combining DevOps and Zero Trust? Very mutually beneficial, right? Now, DevOps, every organization and security team has to adopt, in my opinion, a DevOps approach, right? For the benefits, the reducing the window exposure, and so on. Now, every organization is also going to adopt a Zero Trust approach. But Zero Trust, just like DevOps is a process, in my view, you'll have vendors say, we're a Zero Trust product. Buy our product and you guys will be Zero Trust. Now, we know that's not true, right? But Zero Trust, I like to think about it as more architectural principles, design principles, is where in your environment can you start to enable Zero Trust? Because what is Zero Trust? We assume that our environment is compromised, that there may be an adversary in our network, and as a result, what do we need to do? We need to secure all traffic, which means we need to encrypt and authenticate all of our traffic, ideally. Now, easier said than done. That's why I say, based on those principles, there are many technologies that you can use to start to implement Zero Trust approaches. The cloud providers will all say, if you are cloud first, if you're cloud only, our services are naturally designed to be Zero Trust, right? There's a lot of truth to that. There's an element of truth to that, right? I should say. But you have to do it right. And as we know in our traditional environments that have existed for years, we can't just go immediately tomorrow and authenticate and encrypt everything. We have to do it one piece at a time, whereas there's the most value. So that would be, in my opinion, the technical architectural guiding light, right? For how we approach things.
And we have one last question online, still from Stefan. So thank you, Stefan, for your engagement. So that was a question regarding the legacy infrastructure. So he wanted to know, how could you apply this methodology to your legacy environment and applications, as a lot of what was shown was into modern apps and microservices architecture?
Excellent question. So this came up during break or before the session started. I actually started my career, and in my first job, I was voluntold to do some COBOL and CICS programming on the mainframe and the green screens, and we would do screen scraping to put that stuff into web applications at the time. And I mentioned that here because every organization is going to have some older technologies, probably still even mainframes. You are not going to move those mainframe applications to this modern approach, right? What you're going to do is you're going to start with, hey, what is the most not business critical? What is the, I don't want to say easiest, but where is IT, where is engineering, where's DevOps? What workloads are they moving to this modern stack? And you're going to start there, right? We in security are not going to be driving the shift from, right, mainframe to cloud directly. We're not going to be the ones that are driving the shift from an old vendor application that we're still dependent on to the cloud, right? So you want to take it one bite at a time. Take the easiest bite first.
All right, thank you. So thank you, Frank, for everything. It was very instructive. A big round of applause for Frank.
Thank you.
I hope that you guys enjoyed this. I definitely learned a lot. The first thing that we learned, thanks to Frank, is the 5 key cloud security elements that we need to take into consideration. Identity being the first one, you need to start with your permissions, making sure they're not overly broad. Then we were talking about paying attention to architecture, making sure that you have secure policies, because these are very important as well. Automation is also a very big element. It is one of the biggest help for the defenders, that you need to be able to have and leverage a variety of tools, not only prior to pushing to production, but also as a potential remediation help. Assessment and continuous assessment was also an important element featured in Frank's talk, because that is what helps you know your baseline. And if you know your baseline, you can much more easily find evil. And then again, you had an entire point on detection. Detection, once again, tools can be really handy. You don't need to invent everything. There's a lot of stuff out there. Tools are there to assist you. After the break, Frank continued to do a deeper dive analysis of what you can do for automation. He highlighted the importance of having a security culture that moved from the more traditional, I'll say no, to a security culture, that is more focused on DevOps. Then we had a focus on automation that is not limited to code analysis, but once again, remediation. Don't be necessarily scared of this. This could be something that is useful for you. And one of the key considerations is, of course, to make sure that you have a common format for this to work properly. After this, Freddie, 2 people starting with FR, really. So after this, Freddie underlined a key problem in what we have in cloud security today. And the problem is the shared responsibility model. Because a lot of organizations do not have the in-house expertise to be able to properly implement cloud security. And that what Freddie was showing is that it is a worldwide concern. It's not something that only us are focusing on, but is something that is a problem worldwide. And so even though there was a lot of guidance out there that is, as you said, well-intentioned and well-meaning and properly done, it still puts the focus on the user itself. And that could be the issue. So what Freddie was teaching us was that we need to shift the burden away from the user and onto the CSPs in order to come to a built-in opt-out security by default system. And I also found it very uplifting that Freddie ended with a call to action to compel CSPs to use their expertise and to ensure security by default. So in case you're interested in talking about this, if you want to get involved a lot more, I would welcome you to talk to Freddie, either on LinkedIn or if you're here during the lunch. So our event is now coming to an end. Thank you for everyone who has been attending. Thank you for all of the people online. We also appreciate your engagement, all the questions that were put out there and all the discussions. It is now time to relax. If you are here, please hand out your badges on your way out. Sorry to repeat myself here. For those of you who are following online, but also for those of you who are here, we do have regular events at the CCB. So you can just follow us that you can stay in the loop and stay informed about all the things we're putting out there. For all of those that are here, we have lunch and I can see beautiful sandwiches out there. So thank you again for being here and we hope to see you soon.